9.1 homework, here we go. So the formula that we're going to use pretty heavily here is going to be Fe equals K Q1 Q2 over R squared. Okay, so we got a negative charge of 2.0 times 10 to the negative fourth coulombs. That's going to be our Q1. And a positive charge, all right, that's going to be our Q2 there. Have an attractive force of that. All right, so that's going to be our Fe. All right, what distance, so that's going to be R, are we looking for here? So Q1 is negative 2.0 times 10 to the negative fourth coulombs. Q2 equals 8.0 times 10 to the negative fourth coulombs. Fe equals negative 16,000 newtons, and we're looking for R. All right, so negative 16,000 equals, that's going to be newtons, equals K, right? So our K value here, remember, K equals 8.99 times 10 to the ninth. So that's going to be 8.99 times 10 to the ninth. All right, multiplied by Q1, which is negative 2.0 times 10 to the negative fourth, multiplied by Q2, which is 8.0 times 10 to the negative fourth. All right, all that over R squared. All right, so 8.99 times 10 to the ninth times negative 2 times 10 to the negative fourth times 8 times 10 to the negative fourth. Okay, so I'm going to go ahead and I'm going to multiply this, right, by R squared. So I'll get negative 16,000 R squared equals negative 1438.4. R squared equals, so divide that by, 16,000. I get 0.0899 square root to the square root, 0.0899 square root that. We get an R equal to 0.300 meters. Yes, it's 0.2998. I just rounded it up to 0.3. All right, a negative charge of that, so that's going to be my Q1, exerts an attractive force. Remember, anytime we have an attractive force, our charge here needs to be negative, so that's going to be a negative 65 for our electric force. On a second charge, that is that distance away. Okay, so we got Q1, negative 6.0 times 10 to the negative 6 coulombs. Our Fe here, because it's a negative, or because it's an attractive force, is going to be a negative 65 newtons. And R value is 0.050. K again, 8.99 times 10 to the ninth. And we're looking for Q2 is equal to, okay? Negative 65 equals 8.99 times 10 to the ninth times Q1, which is negative 6.0 times 10 to the negative sixth, times Q2, which we don't know, over 0.050, that's going to be squared. All right, so if I multiply this over, okay, 0.050 squared, all right, so that's multiplied by 0.025, so negative 65 times 0.0025, so that'll be negative 0.1625 equals 8.99 times 10 to the ninth times negative 6 times 10 to the negative sixth. So that's going to be negative 53,940 Q2 divided by negative 53,940. So negative 0.1625 divided by negative 53,000. My Q2 equals 3.01 times 10 to the negative sixth coulombs. Again, capital C is coulombs. That's our charge for this one. All right. Determine the net force acting on the middle charge and the direction of that force for the three charge system below, with K being equal to 8.99 times 10 to the ninth. All right. So if I want to find the force, I'm going to make this number 1. I'm going to do that in a different spot. I'm going to make this the number 1, this the number 2, and that the number 3. All right, so force between 1 and 2, so that's between here and here, all right, is going to equal 8.99 times 10 to the 9th times, this is a 3 times 1.602 times 10 to the negative 19th, and then the charge 2 is going to be 2 times 1.602 times 10 to the negative 19th. All right, all of that is going to be divided by 2.75 times 10 to the negative 9th, and I got to square that. All right, so the top stuff, 8.99, 10 to the 9th, times 3 times 1.602 times 10 to the negative 19th, times 2 times 1.602 times 10 to the negative 19th. All right, so the top bit here for the force between 1 and 2 is going to be 1.38 times 10 to the negative 27th. All right, 2.75, oh, got to put parentheses there. 2.75 times 10 to the negative 9th, all right, squared is going to be 7.56 times 10 to the negative 18th. All right, put that in parentheses. Take that, divided by that. All right, so my force between 1 and 2 is going to be 1.83 times 10 to the negative 10 newtons. All right, so that's one part. Okay, the other part then, and I'm going to switch colors here so you can see a different color, all right, is going to be between 2 and 3. All right, so my force between 2 and 3 is going to be 8.99 times 10 to the 9th times, again, 2 times 1.602 times 10 to the negative 19th, because that's that middle, that's that particle number 2. For particle number 3, that's going to be 5 times 1.602 times 10 to the negative 28, or negative 19. All of this is going to be over 4.25 times 10 to the negative 7th, and that's going to be squared. Oop, you know what I just noticed? I forgot about that negative sign there. So that negative actually needs to go right here, which will make this negative, which will make that negative. All right. Ooh, I almost forgot that. That would have been bad. All right, so the top on this bottom one, 8.99 times 10 to the 9th times 2 times 1.602 times 10 to the negative 19 times 5 times 1.602 times 10 to the negative 19th. So the top bit for this force of 2 on 3 is going to be 2.31 times 10 to the negative 27 divided by 4.25, oops, sorry, got to use parentheses, 4.25 times 10 to the negative 7th squared. All right, that's going to be 1.81 times 10 to the negative 13. All right, so divide those two. I end up with a force here of 1.27 times 10 to the negative 14 newtons. Okay. All right, so now when we look at the direction of the force between the second one and the third one, so between this one and this one, they're both positive, so we're going to get a repelling, right? So this one's going to go that way. That third one wants to go to the right. Second one wants to go to the left. If we look at the forces between these two, right, they're going to attract. So we're going to see that one wants to go that way. That one wants to go that way. So when we see these two together, that becomes a big deal for us. So what we're going to have to do is we're going to have to add for our net force the force of 1 and 2 plus the force of 2 and 3 because they're both acting towards the left. So what that means is we're going to take wait, we don't want negative now. We can just use the total force, 1.83. So let me get rid of that little negative up there. All right, 1.83 times 10 to the negative 10th plus the 1.27 times 10 to the negative 14th. All right, so 1.83 times 10 to the negative 10th plus 1.27 10 to the negative 14. When we add those together, my net force for this one is going to be 1.83 times 10 to the negative 10th newtons. And again, because that force between particle 1 and particle 2 is so big, it actually dominates kind of the overall net force of this. All right, hopefully that makes